Hey guys, what's up? So today we're going to be doing some quadratic inequalities. I'm going to show you how to do them, and we're going to use a bit of drawing to find the answer. Okay, so here you've got x squared minus 9 is greater than 0. So let me just straight out tell you what you want to avoid doing is solving it like a traditional equation. What you want to do is you want to factorize on one side first and then find your solutions. So for example, factorizing x squared minus 9 will be x plus 3, x minus 3, because it's a difference of two squares, is greater than or equal to 0. Now what we're going to do from here is we're going to look at this because we know it's a quadratic. In other words, it's a parabola. And we also know that it's concave up because x squared is positive. So if I draw my graph like that, I know it's going to be concave up. Now I'm just going to put a line across here representing my x-axis. And I know from this bit that my x-intercepts are minus 3 and 3. So where I got that from is I'm basically solving for x plus 3 equals 0. So x is equal to minus 3. And I'm also solving over here, x minus 3 is equal to 0. So x is equal to 3. So basically got minus 3 here and 3. Now what the question is telling us is we want to know when is the parabola above the x-axis, because that means greater than 0. Now here you can clearly see it's up here and over here. So we can represent that using inequality by saying x is less than minus 3, as you can see on the left-hand side here. And on the right-hand side, x is greater than positive 3, because it's above the x-axis. And that's it. Okay, so here's the next one. So x squared plus 2x minus 8 is less than 0. So once again, you want to factorize this x squared plus 2x minus 8 that was less than 0. All right, so factorizing this, we want two numbers that multiply to give 8. So p product, that's sum to 2. So my factors are going to be, oh, sorry, that's minus 8, isn't it? Minus 8. So that's 4 and minus 2. Yeah, so 4 times minus 2 is minus 8. 4 plus minus 2 is positive 2. So x plus 4, x minus 2 is greater or less than 0. So therefore, here I'm going to have x is equal to minus 4, x is equal to 2. So they're just my x-intercepts. That's not the answer. Once again, I know this is concave up because x squared is positive. So draw a parabola, draw x-axis to represent the x-intercepts. So here you've got minus 4 and 2. And now this time we want to know when is this graph less than 0. So when is it below the x-axis? Now here you can see it's clearly underneath there. And it's going to be in between minus 4 and 2. So you need to write it in as one inequality. So x is greater than minus 4 and less than 2. This will be your answer. Okay, so here's the next example. 6 minus x squared is less than or equal to 0. Now, personally, I don't want to work with minus x squared. So what I'm going to do is I want to move everything to the other side. And then by doing that, I'm going to have a positive x squared. The only thing I need to take note of is I need to change this inequality. Okay, so when you move everything to the other side, what you're going to have is you're going to have 0 is less than or equal to x squared plus x minus 6. Now I want in the form like the questions before. So what I'm going to do is I want to switch this position with the 0. And because I do that, I also need to change or flip the sign. So it's not going to be less than. X squared plus x minus 6 is now greater than or equal to 0. Okay. Now, if that confuses you a little bit, just use the little test to show yourself that's true. So for example, I know that 5 is less than or equal to 7. But if I change the order to be 7 and 5, I know that 7 is greater than or equal to 5. So I need to change those inequalities. Now, this is no different to before, so I'll factorize this. So I need two numbers that multiply to give minus 6, that add to give 1. Minus 6, 1. So I think that's minus 3 and 2. So x is minus 3, x is plus 2. So x is equal to 3. X equals minus 2. They're my x-intercepts. Once again, draw parabola. Your x-axis, minus 2 and 3. Now this time I want to know when is the parabola greater than 0. So above the x-axis. So that's here and here. So because they're away, I write two inequalities. So x is greater than or equal to 3 and x is less than or equal to minus 2. Okay, so last example here, I've got y minus 1 all squared is greater than or equal to 0. So this is actually helpful because it's already factorized for me. I've actually got y minus 1 is greater than or equal to 0, okay? Because that's what squared means. Now I know that my y is going to be 1 from that. I know my y is going to be 1 from finding the y-intercept here. I know it's a bit, the letters have changed, but the idea is the same. So your graph is going to only look like this. It's only going to touch at 1. Okay? So it's a little bit more thinking than before. So when is this graph greater than or equal to 0? Well, it's actually this whole thing. Okay? Because it's greater than 0, obviously, here and here. But over here, it's also greater than or equal to 0 at that point there. So my y is going to be all real y values. Or you can write it in this form here. So you can write it as minus infinity to infinity, and that just represents all the real numbers for y. Okay, hope that helped. If you have any comments, let me know down below. Otherwise, I'll see you on the next one.